Welcome to Trigonometry for Pre-Calculus Math 11. Today we're taking a look at the cosine law, which is section 6.5 from the book. Basically in the previous section we saw that we couldn't solve a triangle using the sine law, if you remember the sine law, if we were given two sides and the angle between them. That's still a lot of information. It should be enough information, but not enough for just the sine law, so we need to use the cosine law. So we have the cosine law, which is really based off the Pythagorean theorem a lot. There's a lot of Pythagorean theorem kind of stuff going on in here. And it allows for us to solve for the third unknown side. The cosine law will always work for obtuse triangles as well. So it's good. We can use it for acute or obtuse triangles. So here's a standard triangle, an ABC triangle. And again, I labeled the sides with side A, side B, side C. Same kind of idea. Now, what I have to do is I have to relate a few sides. This proof is going to be a little bit involved. Let's start with the side C. Using Pythagoras, we have C squared is, in this case, Z squared. Z is just that little piece from B to the right angle, Z squared plus Y squared. I need to figure out that A is equal to A is equal to x plus z, and solving for z, we figure out that it is a minus x. What else do I need here? I need that the cosine of capital C, cosine of that angle, cosine's adjacent over hypotenuse, is x over b, which tells me that x is b cos C. And I need the sine of capital C, which is y over b, which tells me that y is b sine capital C. So that's kind of the start information. Those are all the things I need to define. And now what I'm going to do is I'm going to put this into the Pythagorean theorem. So this is what we're going to use. I'm going to go maybe reorder this a little second here. C squared equals, let's just say y squared plus z squared. And let's start making these replacements. C squared, let's see, what is y? It's squared. Y is b sine capital C. That is plus z squared. What do I have for z? Z is a minus x. That's all squared. Let me maybe rewrite this. Let me get rid of that square there. That's b squared and sine squared of capital C. A minus, well, you know what? Let's replace x with what it equals. It equals b cos capital C, and it's squared. Looks like we're going to have to FOIL that out. It's going to be a little bit of a hassle. Hopefully you can follow along with me. The firsts would be a squared. The insides would be minus 2ab cos C. And the lasts would be positive b squared cos squared C. So if you can follow along here, the b squared sine squared c, that's the same. The a minus b cos c, we FOIL that out. I'm just going to do a little reorganizing here. I'm going to say c squared is, there's the a squared. Let me group the b squared sine squared c with the b squared cos squared c. And the minus 2ab cos capital C just kind of hanging out at the end there. We're almost done here. If I factor b squared just out of these two terms, the sine squared and the cos squared, we start to see a handy little identity that we kind of used before, we saw before. And you may remember, sorry, those are c squareds. You may remember that sine squared plus cos squared is actually just 1. It was a couple of units back. So c squared equals a squared plus b squared. That's great. It looks a lot like the Pythagorean theorem, but we have this little extra minus 2ab cos capital C. So it's a bit of a longer proof, a little bit more of an involved proof. There's the cosine law for us for any triangle ABC. C squared is a squared plus b squared minus 2ab cos C, and that applies to any sides. It doesn't matter which side and angle we're talking about. You can just kind of rename it C if you'd like. So we're trying to figure out the missing side C here. Well, what do we need? We need the little c squared to be a squared plus b squared minus 2ab capital cos of c. And we have c squared, that's what we're solving for. A is 12 squared, b is 13 squared, 2 times 12 times 13, and cosine of our angle, capital C, which is 52 degrees. Let me just simplify this a little bit quicker. 144 plus 169. 2 times 12 times 13, that is 312. And let me go ahead and roll cos of 52 through my calculator. You should carry a bunch of decimals. I'm just going to write down 0.6157. C squared is 144 plus 169. That's 313. 312 times that is 192.086. C squared is 120.9136, and taking the square root, we end up with 10.996, which usually we're going to round it to 2 decimal places, and that's what we get. C is about 11 centimeters. So we can see it fits that kind of situation where we have the angle, in this case 52 degrees, and we have the two sides that help form that angle, the 13 and the 12. So a pretty handy little equation. Let's take a look, maybe a little bit of a different version of this. Given the triangle PQR, with PQ being 17, QR being 9, and RP being 11. Again, these could be sides. Let me just draw any kind of random triangle here. It might not be to scale, and we might not actually have a very good idea of what the side lengths are here. Let me try this. Here we go. Let's just label it P, Q, and R. PQ is 17, so that's 17. QR is 9, and RP is 11. Determine the measure of the angle R. So this is the angle that we're looking for here. So if I know angle R, and if we think about the Pythagorean theorem, cos of C, if we're looking for angle R, this needs to be cos of capital R, which means this needs to be small r, and we can use the other sides, P and Q, as the missing two sides. All right, why don't you hit pause there, see if you can roll that through your calculator, figure out the angle R. So R, side R is 17. P is 9, Q is 11, 9 and 11, and cos of R. 17 is 289, 81, 121. 2 times 9 times 11 is 198. And we have cos of R. So isolating for R, again, basic algebra, 289 minus 81 minus 121 will leave us with 87-ish. 87 equals negative 198 cos R. Let's divide by negative 198. We get negative 0.439 with some repeats in there. And that equals cos of R. So arc cos, or second function cos, of that value should give us the angle R. And if you roll that through your calculator, we'll find out that angle R equals 116 degrees. So that, like, we're going to trust that that works. We're going to trust that that size is about right. I think it really boils down to is our picture is actually kind of wrong. If this side had to be 11, I guess let's draw a 17 here just to get a better idea. 11 is going to be a little bit shorter, and 9 is going to be a little bit shorter than that. I think we could probably see that R was probably supposed to be, if that's 116, 11, 17, and 9, that's probably a little bit better picture. But again, we don't know that when we started. Finally, if we take a look at a word problem here, a fence is leaning at an angle of 80 degrees to the ground. Okay, so let's draw a fence. Every good fence has to be some thickness. It's standing at 80 degrees to the ground. So let's draw 80 degrees in there. A rigid supporting brace is going to be used to prop up the wall. Probably a good idea. Base of the support is placed 2 meters from the bottom of the wall, of the fence, and the top of the brace is nailed halfway up the fence. So nailed halfway up. There's our support brace. It's 2 meters away. And it's 1.5 meters up the fence. So there we go. We have, again, another triangle, 80 degrees, 2 meters, and 1.5. So determine the length of the support brace. Let's maybe call that the brace here. We could call that B if you want, or C, it doesn't really matter. And the angle between the brace and the ground. So we're looking for this angle in there eventually. So let's go with the cosine law. Let's call it B for brace. The brace length is going to be 2 squared plus 1.5 squared minus 2 times 2 times 1.5, and we have a nice cos of 80 degrees in there. Why don't you see if you can solve that one on your own? B squared then is 4 plus 2.25 minus 6 cos 80. That's 6.25 minus 6 times cos of 80 is 0.1736. 6.25 minus 1.042, 5.2018, and taking the square root, we get a nice happy 2.28 meters, which, you know what, that kind of makes sense. Those lengths look about right. You know, our angle's about 80 degrees. It's not a huge stretch in the imagination that could be right. The second part of the question is determine the angle between the brace and the ground. So if we have that the length of the brace now is 2.28, we should be able to use the sine law. Sine law is actually pretty easy. Sine of A over 1.5. Let's call that angle A, I guess. And we'll use sine of 80 over 2.28. So therefore sine of A equals sine of A equals 1.5 sine 80 over 2.28. Sine of A is then 0.6479, and we take the arc sine and we find out that angle A is the arc sine of that, and we get a value of A equaling 40.39 degrees, which, you know, we could probably just leave like that. That's fine. There's angle A. So does that look like about 40 degrees? Yeah, you know, it's probably pretty close. This ends the notes for Pre-Calculus Math 11 and the cosine law.